Download this code from codegive.com, link in the description below. Certainly. In this part of the tutorial, we will explore the application of stacks in handling nested brackets, which is a common problem in programming and computer science. We will focus on how to validate expressions containing various types of brackets such as parentheses, square brackets, and curly braces to ensure that they are properly nested and matched. Understanding the concept. When we talk about nested brackets, we refer to situations where brackets are opened and closed in a specific order. For example, the string is valid because every opening bracket has a corresponding and correctly ordered closing bracket. In contrast, the string is not valid because the brackets are not properly nested. Why use a stack? A stack is a data structure that follows the last in first out, LIFO, principle, making it particularly suitable for problems involving nested structures, such as bracket validation. The idea is to push opening brackets onto the stack and pop them off when we encounter closing brackets. Steps to validate nested brackets. 1. Initialize an empty stack. 2. Iterate through each character in the input string. If the character is an opening bracket, push it onto the stack. If the character is a closing bracket, check if the stack is not empty. If it is empty, it means there's no corresponding opening bracket. Pop the top element from the stack and check if it matches the corresponding opening bracket. If it doesn't match, the string is invalid. 3. After processing all characters, check if the stack is empty. If it is empty, all brackets were matched correctly, otherwise, they were not. Code example. Here's a Python implementation of the above logic to validate nested brackets. Explanation of the code. 1. Bracket mapping *. We create a dictionary bracket _ map to easily find the corresponding opening bracket for each closing bracket. 2. Stack initialization *. An empty list stack is initialized to keep track of opening brackets. 3. Iteration *. We loop through each character in the input string. If it's a closing bracket, we check if the stack is empty and get the top element. If it doesn't match the expected opening bracket, we return false. If it's an opening bracket, we simply push it onto the stack. 4. Final check *. After processing all characters, we check if the stack is empty to determine if the expression is valid. Conclusion. In this tutorial, we have discussed how to use stacks to validate nested brackets in expressions. This is a fundamental application of stacks in computer science, and mastering it can help you understand more complex data structures and algorithms. You can further enhance this example by adding error handling or supporting additional characters as needed.